In this video, I'll discuss truth tables and show relationships used for negations. A truth table is a table which displays truth values and is used to evaluate arguments and to help illuminate common relationships. The simplest truth table involves one statement. The most that we'll look at will involve two statements and a few three statements. To set up these truth tables, we need columns for each statement involved and then columns for the compound statements to be evaluated. I'll call the rows the top row, and then row 1, row 2, and so forth. For one statement, the one statement case, we'll have a statement, let's say P, and we'll want to list all the possible truth values. Well, P can be either true or false, so all of the possible truth values will involve just T and F in row 1 and row 2 respectively. And we would follow that with some compound statements. If we have two statements, we want to be careful to list all of the possible interplays of true and false between both P and Q. The way that we'll do this is we're going to write out true, true, false, false for P, true, false, true, false for Q. This is the standard way we'll do this, and this is what I'll expect you to do. What we should see here is that there's a total of 4 rows, which comes from the fact that each of P and Q have 2 possible truth values. To get the overall result, we're going to take 2 times 2 and see that there are 4 interplays here. In fact, what they are is true, 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 false, false, true, and false, false for those values. Again, true, 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 false, false, true, false, false. For the 3-statement case, each of P, Q, and R again has 2 possible truth values. Multiplying 2 times 2 times 2, I should see that there are 8 different rows we'll need in this truth table. Alright, the way that I make this is I'm going to first separate out the P's as the first half true, the first 4 are true, and the last half are false. The last 4 are false. And then coming on down to R, it goes true, false, true, false, true, false, true, false. It alternates through. As I move from P to R, Q gets increasingly more disparate. Again, it's true, true, false, false here for Q. True, true, false, false is the order that Q goes in. This is the standard for 3 statements, and that's as big as we'll get in this class. Let's look at how to set up a truth table involving negation. We'll start with the standard table for one statement and add a column for the negation. And I'll write the negation of P here. Now, let's look at what the truth values of the negation of P would be in each of these cases, that is, in each of these rows. Again, what we have in this first column are the possible truth values for P, and what we're saying here is that P is true in row 1. Well, if P is true in row 1, the negation of P, which should have the opposite truth value, will have to be false. The negation of P in row 2, well, in row 2 we're saying that P is false, so the negation of P would have to be true. And this would be a truth table involving the negation. Again, all I did was I negated whatever this statement here was representing. And I'll kind of say it a slightly different way. Regardless of what this statement involves, the negation is going to give you the opposite truth value. Another way to look at this, and I'm going to write this down. If P is true, well, the negation of P is false. Otherwise, the negation of P is true. Again, to reiterate, another way of looking at this, and this is a little strange to do by hand, we'll see why we want this later. If P is true, the negation of P is false. Otherwise, the negation of P is true. Have fun with logic.